So we've got 3 external walls. The only wall that's exhibiting a problem is the rear wall. And we've got a positive grade where the backyard is rolling a bit down towards the back wall here. And we've got a classic 6 blocks high. We're seeing moisture and some organic growth on the wall. And the wall gets wetter and wetter and wetter the further you go down. So we're going to put in a below floor drainage system to relieve water pressure that pushes up from below. And we're also going to put in a negative side water control system you'll see in a minute. And what that does is that vapor barrier encapsulates the foundation and segregates the foundation, which is wet, a little bit nasty as you can see, from the living space. And you can see the system is put together. It's 10 to 12 inches wide, it's 10 to 12 inches deep. There's a layer of stone, the perforated pipe, and then another top dressing of stone. The fellows are getting ready to put this, it's called putting the system back together now. They'll put the drain board and fresh concrete up. So part of what was identified in this job was, as we saw earlier, water coming through the wall. And in this case, we're employing a bentonite injection methodology whereby we saturate the ground on the outside of the wall with a material that water can't pass through. And they're taking the bentonite from a granular form, hydrating it in a pumping barrel. It's got a pump mixing it. And once it gets to a slurry consistency, they'll begin to inject it into the ground. And we hang this vapor barrier on the wall so that in the event of water penetration through the wall, that water is controlled behind the vapor barrier, and it'll have access to the drain system below the floor. So prior to installing the wall board or the negative side water control system with a vapor barrier, we don't want to encapsulate any kind of suspected organic growth. So we'll always treat the wall with an antimicrobial, one of several kinds that we use, but they're all geared towards chemically destroying suspected organic growth that we run into. So the system installed is designed to attract, direct, and remove the water. And the removal part is what we're going to cover next, and that is a sump liner and a sump pump. So the system itself attracts water and directs it to this hole that we've dug. Now the hole is backfilled with all of the stone. We use large plant 5 stones, so it allows a lot of water to pass through it. This is the collection area for water. And here we have the main part of the system, the drainage pipe, the perforated drainage pipe, and that serves as a conduit for water in the heavy influx of water times in the 30-year flood. When you get 2 inches in an hour, then you'll see water in a pipe. Other than that, the water will migrate through the stone, end up in the low part here where the liner is. So in here we have the system pipe, we have the discharge pipe, the green is the sump pump, and then this is a little trick thing we do with to rough in for the electrical conduit because we don't like perforations. The system itself attracts and directs the water to the lowest part of the system, which is where the sump liner is. And the sump liner serves to keep back dirt and stone, but allow water to bleed into it readily. So let me manually activate the pump and I can show you how low it can pump it. And that little spray of water you see down the bottom is to keep the lower section of the pipe between the check valve and the pump open so the pump doesn't get airbound. And that's the operation of the evacuation part of the system. So in this case, because there was an existing waterproofing system in place, we've tied into the existing discharge pipe. And the discharge pipe is where the pump pumps the water. We pick the water up and remove it up and outside. Since the client already had a discharge pipe, rather than make a new opening, we utilize the existing discharge pipe.